topics. In this video, we are going to explain about a project titled An Innovative TOPSIS Framework in Hesitant Fuzzy Using Multi-Criterion and Multi-Objective Group Decision System for Breast Carcinoma. Now coming to the introduction part. The introduction of this innovative TOPSIS framework in the context of breast carcinoma is expected to significantly enhance the decision-making process for medical practitioners and improve patient outcomes. By incorporating multi-criterion and multi-objective considerations and effectively handling hesitant fuzzy information, this framework holds great promise in the domain of medical decision-making for complex diseases like breast carcinoma. This framework harnesses the potential of hesitant fuzzy sets to address the multi-criterion and multi-objective nature of group decision systems in the medical domain. By combining these two methodologies, the proposed approach aims to provide a robust and comprehensive decision-making system for breast carcinoma. So our main objective for this project is to improve patient outcomes and enhance the quality of care for individuals diagnosed with breast carcinoma. By offering a robust and efficient decision support system, medical practitioners can make well-informed and personalized treatment choices that align with the specific needs and preferences of each patient. The proposed framework seeks to contribute to advancements in medical and decision making and offers a valuable tool to aid in the fight against breast cancer, leading to better treatment strategies and ultimately improving the lives of patients affected by this challenging disease. Breast carcinoma treatment decisions typically involve considering various criteria such as treatment efficacy, side effects, costs, patient preferences, and ethical considerations. By taking into account multiple criteria simultaneously, the framework aims to provide a more balanced and informed decision-making process. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required. Processor i5 and above. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first upload textile dataset. The first step in this process is to gather a dataset of textile images. This dataset will serve as the foundation for training a convolutional neural network to recognize and classify different textile items. The dataset should consist of various textile images, each labeled with their corresponding categories, that are cotton, silk, wool, etc. The dataset's size and diversity are essential factors that can influence the CNS performance and generalization ability. Second, train dataset with textile images using CNN. Once the textile dataset is ready, the next step is to train a CNN model using this dataset. A CNN is a specialized deep learning model designed to work efficiently with image data. During the training data process, the CNN learns to extract relevant features from the textile images and map them to their respective categories. The training involves adjusting the network's parameters through forward and backward propagation to minimize the prediction errors and improve the model's accuracy. Third, recommend compatible items. After successfully training the CNN model, it becomes capable of predicting the category of a given textile image with a certain level of accuracy. Using this trained model, we can build a recommendation systems that suggest compatible textile items to users based on their input. For instance, if a user uploads an image of a cotton shirt, the system can recommend compatible clothing items or accessories made from cotton, such as cotton trousers or cotton scarves. Fourth, accuracy and loss graph. During the training process, the CNN model's performance is typically evaluated using metrics like accuracy and loss. Accuracy represents the proportion of correctly classified samples in the dataset, while loss indicates how well the model is performing in minimizing prediction errors. By plotting these metrics over successive iterations during training, we can visualize the model's learning progress. The accuracy graph shows how the model's accuracy improves over time, while the loss graph displays how the model's prediction errors decrease during training. Now coming to the execution part, to execute the project, first we need to open the code folder. So here in this folder, we have a Python file which is containing the Python script in it. And here this dataset folder is containing the dataset in it. Here, main file and TOPSIS file are the Python files which are containing the Python scripts in it, and here this is the main Python file. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload breast cancer dataset button to upload dataset and for getting the output. Here I am selecting this dataset and now click on open button to load the dataset. Here it is displaying few records from dataset, and these records are in strings format and we need to convert to matrix. So for converting into matrix, click on generate matrix button to convert above dataset into numeric matrix using Python sklearn label encoder. So here all dataset is converted into numeric format and then generate above matrix, and now click on calculate fuzzy TOPSIS decision making matrix button to apply TOPSIS algorithm to make decision of disease stages and to get the result. So here in this screen, all columns contain dataset details and TOPSIS weighted total column contains output value from TOPSIS algorithm, and based on that output values we have calculated class labels as disease stages. So now closing this window and executing with this program over here. So now coming back to the conclusion part, as medical research continues to evolve, the integration of innovative frameworks like the proposed TOPSIS approach will likely play a crucial role in advancing medical decision making. By embracing the potential of hesitant fuzzy sets and multi-criterion analysis, the medical community can continue to make strides in addressing the challenges of breast carcinoma and other complex diseases, ultimately paving the way for more efficient and patient-centered healthcare practice. Moreover, the integration of multi-criterion and multi-objective considerations enables a comprehensive evaluation of various treatment options, taking into account diverse factors that impact patient care. The framework allows medical practitioners to make well-informed decisions that align with patients' individual needs, preferences, and overall well-being.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.